What is going on, guys? My name is Anson, and today I'm going to teach you guys how to get started with setting up a load balancer. This is going to be an actual full course where what we're going to do is we're going to create a couple of DigitalOcean droplets. We're going to create a load balancer. We're going to deploy an application on all of these servers, and then we're going to set it up so that way the servers are going to receive traffic from the load balancer. We're also going to set up a domain name so that way we can actually set up things such as a certbot and let's encrypt with so we can get SSL. And I'll show you guys how the communication is going to be traveled. Okay, so this is going to be a full tutorial. Okay, I'm going to try my best to cover as many things as I can. I myself am still learning about load balancers, but I really find them very interesting, and I'm really just trying to share what I learned with you guys. So one thing that I do want to mention is that we are going to be using DigitalOcean, but really the knowledge that you'll be learning from this video can apply to really anything. So just because we're using DigitalOcean doesn't mean that you should click away from the video if you use something like Linode or AWS, because realistically, the concepts that we're going to be going over, the process is really going to be similar to how you would do it with other providers. So for example, if you use Linode, Linode has their own product called Node Balancers. I think this is the equivalent. And it pretty much has many of the supports that you would find with DigitalOcean. You can see they have multi-port balancing, they have session persistence, SSL termination. I've never used Linode before, but I've heard many good things about Linode, so I would recommend it. But we're going to be using DigitalOcean because I personally use DigitalOcean for all my projects whenever I need to deploy them. And I've never really had a problem with DigitalOcean for the past 3 years that I've been using their services. Okay? So what we're going to do is we're going to discuss a little bit about load balancing and what it is and why you might want to consider using load balancing. And we're going to basically do a hands-on tutorial where we're going to actually go in and set up a load balancer. And, like I said before, we're actually going to be talking about what load balancing is and going through an actual workshop. Okay, so what exactly is load balancing? So I'm going to start off with an analogy so that way you guys can try to pair the analogy with how load balancing is applied when it comes to web traffic. So let's say, for example, you are an individual human being and you decide to open up your own business. Let's say you want to open up a new pizza shop. Let's say that pizza shop, has, let's say, 100 customers a day. Maybe 100 when you first start out. And as your pizza shop grows, you might need to hire more employees. Let's say when you start out, you only have maybe 2 or 3 employees. That serves 100 people a day, 100 customers a day. And 1 month goes by, your pizza shop becomes more popular, and your customer load grows from 100 to 1,000. Now you see that a lot more customers are coming in, and one thing that you notice is that the lines are literally insane. People are lining up literally out through the door, and you tell yourself, or you ask yourself, should I do something about this? Should I hire more people? What should I do? So let's say, for example, you currently have 3 employees, and you have 1 employee that takes care of making the pizzas. You have 1 employee that takes care of managing making sure the pizzas are well done, well cooked, and you have 1 person that takes care of the cashier. Now, how you manage your pizzas or how you manage your customers is really up to you, okay? But it comes a time where you run into limitations. You run into bottlenecks. Let's say, for example, there's only so many employees you can hire at your local pizza store that you need to start buying a new location and opening up a second pizza store that's under the same brand. Maybe it's chain or franchise, whatever it is, right? You want to create a second physical location, so instead of customers all going to the actual one individual pizza store, they can actually go to a secondary one. And what I'll do is right now I'll actually draw a diagram so that way you guys can actually see where I'm going with this. Alright guys, so I'm going to use Miro Whiteboard, which is a really nice tool. It's also free, just so I can draw out this diagram so you guys can understand this a lot better. So let's say, for example, we have a physical location Okay, we purchase some real estate and we can use that real estate to set up a business. Let's say we want to sell pizzas. So we set up the store, we hire a couple employees. Let's say we hire 2 employees. One employee is responsible for making the pizzas, the other employee is responsible for serving the customers. That could be, being the cashier, handling transactions at the point of sale, whatever it is. Okay, we have a total of 2 employees. How you manage your business at the store is up to you. Okay, and should you reallocate resources? For example, should you hire more employees or fire employees is up to you. But let's say we have 2 employees at pizza store number one, and each day we're capable with only 2 employees to serve 500 customers a day. Okay, so that's just probably like, maybe a 10-hour shift or 8-hour shift. You serve 500 customers a day. And each month you're able to serve 15,000 customers a month. Okay, now let's say this probably works for you for maybe 1 to 6 months. But let's say within those 6 months, your business, your pizza store, becomes more and more popular. So what I mean by that is many people like your pizza. All of your customers are satisfied. They tell the people. Maybe you might also invest into money in marketing so people know about your pizza store a lot more. So you start to realize that, wow, there's so many new customers coming in, and you look at your analytics, and maybe on the third, fourth, and fifth month, maybe you realize that your customers per day and your customers per month and all your analytics are growing, and it's telling you that your business is growing. So let's just say, for example, that let me write this down. So let's say 6 months later, our let's say pizza store number one is, let me kind of like, not this, whoops. Let me just kind of like do that. Hopefully you guys don't have trouble seeing this as well. I'll zoom in as well. So let's say, for example, pizza store number one is serving, let's say within 6 months, this store is capable of handling, let's say, 2,000 customers a day. And so when you do the math, so 2,000 times 30 would basically be equal to 60,000 a month. Okay, so obviously, if you have more customers, you're more than likely going to need to hire more employees. Okay, so let's say, for example, as time goes by within those 6 months, you also have, let's say, for example, your employee count went from 2, and let's say you hire a total of 8 employees, or you hire 6 more employees. Okay, so in comparison, you can think of this like if you were to scale up your server vertically, you're basically increasing the resources allocated for that server. So what that means is you're increasing the amount of CPU cores, so that way you can process things a lot more quicker. You're increasing your CPU cores, so that way your processing output can become more efficient. You're increasing your RAM, so the amount of memory that your application needs to hold. So in our case, we'd essentially be hiring more employees. So you can think of the employees like an individual CPU core that can handle something. Okay, and the result of this is we have employees. We have 2,000 customers a day and 60,000 customers a month. Okay, so you can compare this to vertically scaling an actual cloud server where we can add more RAM and more CPU usage and even more storage as well. Okay, whatever resource that we can vertically scale. Okay, now when it comes to vertically scaling, there are limitations because there's only so much RAM and there's only so many CPU cores or so much cores that you can have on a single virtual machine that you need to start horizontally scaling. And horizontally scaling is basically where you're adding new physical, or not physical, but virtual machines. Okay, in our example, we're basically going to be adding new physical pizza stores. Okay, so the reason why I'm mentioning these two comparisons is so you guys can see where I'm going with this. Okay, so when we vertically scale our pizza store, we're going to hire more employees. You can think of the employees as an individual CPU core, or maybe an individual CPU. Okay, and you have other resources that you might allocate for the pizza store. Maybe you might hire someone else to manage, other things too. Whatever it is that you need to get your business running effectively. So now let's say, for example, there's only so much that we can do for pizza number one. There's only so many employees that we can hire for this specific store that serves the current market it's in. Okay, so what do we do next? Well, we horizontally scale, or in other words, we create another physical store or physical location. And in the real world, if you have a business that operates physically, your version of horizontally scaling wouldn't be going on a cloud server and purchasing a new virtual machine. You would actually need to buy a new physical, you'd actually need to buy an actual asset, like an actual real estate asset. So let's go ahead and just copy this. And let's say we bought pizza store number two. And let's say we have an idea in mind where pizza store number two is going to be even bigger and it's going to serve even more customers. So it might cost a little bit more, but we have enough money from pizza number one to support this, right? And like I said, it's the same idea that you have in mind, where let's say your startup does so well and it operates on an 8 gigabyte, 32 gig RAM, an 8 core, 64 gigabyte RAM virtual machine, right? You're making a lot of money from just that, and it probably only costs maybe like $100 to $200 to run that application on the server. And so you're saying, okay, well, I'm making a lot more money each day from this pizza store. I can definitely afford a larger scaled droplet or virtual machine to handle even more customers. Okay, so you might put in more money into this physical location. Maybe you want to have this store be in a more populated district in your neighborhood, maybe in like a more populated area. Like, for example, there's many populated areas in New York City, in Manhattan. So maybe you want to put that there. And you also need to make sure that it has enough space. Okay, so let's say, for example, pizza number two is going to be a lot bigger, and let's say we hire, let's say we hire 32 employees, and we can pretend that these 32x CPUs. Okay, and then we can go ahead and say, okay, well, each employee is obviously capable of doing only so much. Okay, so we're not going to really make the analogy with the RAM, but let's go ahead and say, well, we have a bigger store and we have more employees. Okay, and we're also serving even more customers because this could technically be located in a bigger district. So let's say, for example, we run the store, and let's say 1 month goes by and we see that the results are in. We see our analytics, and that's why analytics are also very important because it helps you monitor your business. So let's say the results are in, and from this pizza store, we are able to serve a total of, let's just say, let's see, I'm trying to think of a good, let's say we're able to serve 12,000 customers a day. Okay, and these numbers are obviously arbitrary. It could be even more or less. Okay, it's really arbitrary. Okay, so we serve 12,000 customers a day, so that would basically be 36. So that would essentially be 3,600,000 customers a month. Okay. So you have 12,000 customers a day, and you have 360,000 customers a month. So 3,600,000. So when you scale out your application, you have 12,000 customers a day, and you have 360,000 customers a month, which I would say, it's pretty good. Okay, but let's say, for example, you think that, let's say, for example, you have your own analytics and you think that this is really not enough, right? compared to what it is for this store, because obviously you always want to make comparisons, right? Let's say for example you feel like 32 employees is way more than what we need, okay, and you feel like you might be able to produce better results with less employees. So what you can do is you can do something called scaling down, and this is where you do something such as firing employees, which does happen in the real world, right? So you fire an employee, okay, and let's say 1 month goes by and your analytics, your customers per day and your customers per month maybe stays around the same number as you see over here. So that tells you one thing, that you hired way too much, but it's okay because, like I said, you're making a lot of money from the pizza store number 1, and it's not like you're really losing money in a say. You're still making money from pizza store number 2. It's just that you're minimizing your costs by firing employees. Okay. Now I'm not saying that that's the right thing to do. Okay, it's not always the right thing to do, because you can definitely allocate those resources to doing other things too. Maybe, for example, maybe you might decide to keep all 32 employees, but not all 32 employees do the same thing. You might distribute certain tasks for certain resources, or you might distribute tasks and resources for certain employees, right? And that's something what you would do on the server. You would assign certain tasks for certain things to be executed on a certain time of day, or whatever it is that you need to be done. Okay, so in a nutshell, you can basically think of our pizza store analogy as a way where we can scale our physical or in-person business, okay? And you can relate that with an actual software that lives on the cloud. So when you have many customers, instead of all of those customers accessing the application on one single server, what happens is you have multiple servers where the application can be hosted, and the customer can actually access the application via a load balancer. Now, one thing that I should mention is that the load balancer would essentially act as a middleman. So you can think of it like this, and we're going to step away from the physical pizza store. Okay, so you can think of it like this. Let's say, for example, this is the load balancer. Okay, this is our load balancer, and let's just label this as load balancer, and let me just kind of like, let me make this a little slightly bigger. Okay, so let's say this is our load balancer, and we want this to connect to several nodes or several services or servers, right? So let's say this is a server 1. Let's call it server 1. Okay, and we're not building any microservice. All we're really doing is just creating a new virtual machine. That's really it. So this is server 1. This is server 2. And this is server number 3. Okay, let's go ahead and just draw this out. Hopefully this will let me. Perfect. Perfect. Okay, so we have 3 servers. Okay, now these are, like I said, these are just virtual machines. Those virtual machines can have something like Nginx, and Nginx is a reverse proxy where it can pretty much allow you to set up a complicated web structure. So with Nginx, what we could do is, for example, we can have server 1 hosting the same application that server 2 and server 3 will host. So let's say, for example, so think of it like this. Our pizza store does really the same thing, though. The same purpose of the application or the same business is to serve pizzas. Okay, so our application doesn't change. It's just that we're hosting the same instance of the application on its own server. So instead of having it on one server, we have it on 2 more servers. Okay, and each one of these servers can have its own allocated resource. So let's say server 1 has, let's say, 4 gigabytes, or let's do 4 CPU, and actually, yes, 8 gigabytes. I'm trying to make it realistic. And let's say, and like these numbers can differ. Okay, these can even be physical machines as well if you have your own physical servers. So let's say server 2 is slightly going to have more resources, so 8 CPU, and let's say this is 16 gigabytes. I think it typically should be 32 gigabytes, 8 CPU, 32. I think for servers at least, and with 4, it should be 4 and 16. And let's say server 3 has some. Let's say it's going to be a 16 CPU, 64 gigabyte. Okay. Now with load balancing, there's different algorithms that you can have the load balancer be configured, so it knows how to distribute traffic to each server, because not every single server might have the same resource allocated. Okay, so you want to make sure you're not distributing too much load to, let's say, server 1, where we have, only less resources allocated. We only have four CPUs and 16 gigabytes of RAM compared to server 2. Ideally, server 3 could be the server that takes the most traffic compared to server 1 and server 2. Now, I'm going to go ahead and draw one more diagram just to show you guys what it would look like if we did not use a load balancer and we had just had like a standalone application. So let me go ahead and just duplicate this, and let's just call this end user, and let me just duplicate this. Okay, and let me just call this Ubuntu server. And like I said, this could really be any server from any cloud hosting provider. Okay, so let me go ahead and also just create a label over here. Okay, so without a load balancer and with a load balancer. Okay, so without a load balancer, you'd basically have your end users, so that could be your customers, right? And the customers would visit your application, and that application would make requests to the API. Ideally, basically the Ubuntu server would run something like Apache or Nginx, and Nginx would host, or Nginx would serve your static files, so either the React app in static, like the static files of the React app, or like the static files of the Angular app, or whatever framework you decide to use. Okay, so it would just be one, or it'd be whatever users, right? Any users, and they would communicate with one single server. Okay, and you can kind of see why that if your application does get bigger and bigger and bigger and bigger and bigger, you can kind of see why it makes sense that we want to scale, and we want to essentially make it so that instead of having one server take up all the traffic, we can have multiple servers have the same application hosted and have traffic distributed however we wish. So for example, end user 1, end user 2, end user 3. Let's say you have 3 or many more customers that want to communicate with your application. Okay, so they would basically be communicating with this one single server. Okay, and let's say this grows to, let's say, 10,000, 20,000, 1 million users. You can start to see why having only one server serving 1 million users can become very, 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 very bad, because that's just all that traffic going into one server. Okay, with load balancing, however, what happens here is instead of having the users communicate directly with the actual server or making the request directly to the server, what happens is the user actually communicates with the load balancer. So let me draw this real quick. So let's just say we have end user 1, we have end user 2, end user 3. And like I said, this is one way that we can kind of like draw out this architecture. There's many different architectures that you can create, but this is just one way that I would at least go about it. And let me just kind of like move this over here. Okay. All right. So this is what it looks like with the load balancer. So we have an arbitrary number of users, and these users make a request to the load balancer. Like I said, the load balancer is really just, you can think of it like another server. It has its own host name. So it has like an IP address, and you can actually add a DNS record for that. You can add a domain name for that. Let's say, for example, we have a full stack application, and typically, if we have just an application without a load balancer, the Ubuntu server would have the host name, right? We'd have the domain name mapping to that host name, so that way we can visit it with the domain name, and we would get back the contents that we request. Okay. Instead, what we would do is we would apply the domain name to the load balancer, and the load balancer, using traffic rules, would forward requests to each server. Okay, So let's say, for example, end user makes a request to our domain name. Let's say this domain name is something like coding.com or example.com, whatever. It could be any domain name. That domain name or that load balancer with that domain name is going to receive that request. And what's going to happen is that domain name or that load balancer is going to forward that request to either one of our servers. So it could be server 1, server 2, or server 3. Now, with load balancing, there's something called an algorithm, okay? And you can actually configure your load balancer to route request however you want, okay? So, for example, let me kind of show you guys this. This as a reference. So you guys, so let me show you. So, for example, over here on Nginx, and like I said before, you can also use Nginx to load balance. So for example, there's the round robin algorithm. So essentially, by default, your load balancer will be configured to use round robin, or at least that's what DigitalOcean has configured to. Okay. So the round robin algorithm basically will propagate traffic to each server. So for example, it'll go to server 1, then server 2, then server 3, and back and forth. So round robin. Okay, so we'll cycle through all 3 of these servers, and you'll see that example later on. Okay, there's also least connected, so it can assign, it can forward that request to the server with the least number of active connections. There's also IP hash, so that's a good way to kind of like assign a server to a user based on they do it with the client IP address. And that's actually good when you want to have a more persistent application. There's also something called a sticky session with load balancers. So basically, if your application has state, so let's say you have the user log in and log out. If you don't have a sticky session, the load balancer is going to cycle through each server, okay? And it's not going to be consistent. So the users will be able to visit the application, and even though they're logged in, sometimes they'll be logged in and sometimes they'll be logged out. So you want to make sure that you have something like sticky sessions enabled. And I'll show you guys how that works when we actually set up the load balancer. Okay. So yeah, so pretty much in a nutshell, the load balancer is a server. Okay. It's really all it is, just a server that handles forwarding traffic. Each server, we're going to have Nginx set up for each server. Okay. And on the Nginx server, we're going to have it forwarding requests to the front-end application. So whenever the user visits the application, they'll see it. And then it'll forward a request to its corresponding API. Okay? So essentially, each server is going to have its own React or Angular application. And it's going to have its own backend application that it communicates with. Okay? And I'm going to show you guys how we're going to set this up. So that's essentially it with load balancing. In a nutshell, that's a general overview. I really hope that this explanation made a lot of sense, especially with the pizza store analogy. And I really hope you guys understood how the load balancer work, and I hope I was able to explain in a way where you guys were able to understand it. Okay. We'll go more in depth on load balancers later on, but I think what would be better is if we actually go ahead and use a load balancer with DigitalOcean. So let's go ahead and get started. So in the next video, we're going to go ahead and jump into a more hands-on activity where we're going to set up a load balancer. We're going to set up multiple servers, and we're going to deploy an application that I already have created. And then we're going to see how traffic is distributed. So I'll see you guys in the next video. Peace out.